Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline, you'll need somewhere to deploy it, so you should check out Linode. With private networking, shared block storage, node balancers, and a 40 gigabit network, all controlled by a brand new API, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode to get a $20 credit and launch a new server in under a minute. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. Your host is Tobias Macey, and last week I attended the Open Data Science Conference in Boston and recorded a few brief interviews on site. In the second part, you'll hear from Andy Eschbacher of Carto about the challenges of managing geospatial data, as well as Todd Blaschka of TigerGraph about graph databases and how his company has managed to build a fast and scalable platform for graph storage and traversal.
My name is Andy Eschbacher. I'm a data scientist on the research team at Carto. I work on problems for clients, largely with spatial data. We solve their problems on Carto's platform. I also build tools to help data scientists use Carto more natively in a data science environment. One of the products that we have is called Carto Frames. It's a Python package for using Carto in Python environment, and it shines in Jupyter notebooks. And we also work with partners who provide us with spatial data that they either want advice on or they want to surface it on our platform for consumption with our clients.
And a lot of times dealing with geospatial data can be challenging just because it's often either misunderstood how to work with it best, or you might not necessarily have the right tooling or techniques to source it properly and label it appropriately and then be able to make use of it at the destination. So I don't know if you want to talk a bit about some of the solutions that you've built as far as being able to store and surface some of that capability in your platform.
Yeah, as most people know, a lot of the work for data science outputs, 80% of the work is just getting the data in a good form. One way that we're trying to handle that is we don't want data scientists necessarily to work on Carto's web platform to do that. We wanted to build a product like Carto Frames where they can work in Python Pandas or whatever tool that they want to use in a Python environment so that they can do all of that data munging and stuff like that. And then they can push the data up to Carto and maybe do some additional data processing off of that. Other ways that we have for data analysis and data processing, in Carto we have analysis chains where you can apply an analysis that they're all related to each other. And if the underlying data source changes, the analysis bubbles up. So maybe you want to do a filter, then you want to do some sort of cluster analysis, and then you want to visualize the output of that. Carto will handle the various nodes of that and then surface the output that you're interested in. And then the endpoint of that, you get an interactive map, and you can add widgets to that map and then do filtering off of the widgets to tell the story that you're interested in telling.
And do you find that there are certain common misconceptions or mistakes that people fall into when they're dealing with geospatial data?
Yeah, data quality is a big problem in geospatial data. I think that so if you're working with GPS data, the margins of error, depending on the quality of your data, can be 10 meters or it can be 50 meters or even greater than that. So trying to get your data into a proper form can be very challenging, and making informed decisions off of the data, there's a lot of nuance and very much an art in getting the geospatial data in the correct form. A lot of the times with data like GPS data, you want to aggregate it to a small boundary. Sometimes you want to do like a hex grid or like a 100-meter square, and then you're telling the story of like what was the summary of maybe foot traffic data in this location at this time of day, this day of the week. There's obviously margins of errors that go along with that, but I think with any analysis that somebody does, communicating the errors is especially difficult, and trying to convince whoever is looking at that this is an output that you have, but communicating the errors on a map, I think that there's not a good standard way for doing that right now. And so by having additional components that you can add to it, like the widgets for doing filtering or communicating like residuals and things like that, we're hoping to help take away some of the certainty that people have about visualizing spatial data and really looking at what the residuals tell you in an interactive map application.
And as far as collecting the geospatial data, it can come from myriad sources, and whether it be somebody's smartphone or IoT sensors or just housing address or IP. So I don't know if you have any particular techniques or issues that you faced in terms of collecting that data and storing it in a manner that can be unified and addressed in a uniform and sort of tractable manner.
Yeah, that's something that we're working really hard on right now. We definitely don't have it solved yet. One thing that we're working on, so the GPS data is especially messy. The data cleaning, we found about 80% of the data we have to throw out because there are various inconsistencies. Maybe you have a ping at the same point, or maybe you have two pings that are far apart and faster than light speed travel. And so you have all of these conditions that you have to look for in the data cleaning process. And so you end up losing about 80% of the data. And then the 20% that you have, you want to make sure that's representative of the population that you're looking at as well. And each data set's different. So spending a lot of time with the data, trying to understand those nuances and quirks, and speaking to the people who provided it so that you can understand where they're coming from and how they collected it. Some of the quirks that you have is the device might not sync for a couple of days, and so the timestamps might not be as accurate as you think that they are. In cities, there's a lot of scattering off of buildings, and so you don't really know very well where the person was. And so there, some of the efforts that you can have are just to snap to a road network so that you can just make an assumption that this person probably was on the road. If they were in a building, that building wasn't very far away from where they were. And then since each data set's different, combining those data sets to give representative samples. So if you're interested in this footfall problem, so how many people walk on this sidewalk at 10 p.m. on a Sunday or something like that, being able to pull in multiple sources and then using techniques to try to make good predictions off of what the actual footfall was, and then validating that with some known sources is the process that we're going through right now. We definitely haven't solved it. It's a hard problem, but yeah, that's one of the core problems that we're working on our team right now.
And there are a lot of different standards for storing and processing geographical information, whether that's GeoJSON or raster files or vector files or some other maybe proprietary schemas. So are there any particular technologies that you've settled on for trying to unify that storage?
So Carto is pretty agnostic to data storage. One thing that we rely heavily on is the open source community around geospatial. So Ogre to Ogre is a great tool for transferring. When people pull their data into Carto, it's in a PostgreSQL database that has PostGIS on it. And so Carto stores the data in a database. That data transformation step is really hard. So we built tools like CartoFrame so that people can do that ETL process for themselves. We support almost all of the major formats for data, both for input and for outputs as well.
And what are some of the most interesting or innovative uses of the Carto platform that you've seen?
One thing I'm especially excited about right now is we just released a React library, so you can build an application using Carto pieces of Carto, and then you can use our vector library and other tools like turf.js to do some of the spatial processing on the client. And then once you do that spatial processing on the client, you can send that up to Carto and then do maybe more spatial processing that's like maybe more data intensive on the server. So the number of tools that are coming out that allow you to build these applications that take different advantages of different parts of the tech stack and allow you to iterate quickly over building these projects, I think is especially exciting right now. So what you can do with vectors is really exciting. Being able to rapidly build prototypes or dashboards with React, being able to do server-side applications, being able to build applications with Python using Carto frames. One example that we have that pulls a lot of these things together is we do an ETL process using Carto frames. We're using open data off of Big Belly trash cans here in Boston, and they report the status of how much trash is in there. And then we want to try to we're building a model to make predictions based off of footfall and other things, other demographic information in Boston on how often these should be emptied. And so the process for doing that is we had the ETL with Carto frames. We sent that table to Carto. We built a dashboard using Carto VL and Mapbox GL. And we did, like I said before, some of the spatial processing using turf.js in the browser. We visualized the data using a React library called React Viz. And then we built a special PostgreSQL extension that allows us to store the output of a model. So we trained a model based off of a number of features. We stored the model on Carto in a table, and then then once we got new data later, we referenced that model to make new predictions, and then we also extracted feature importance to communicate the results to the user. So being able to not only visualize the data, but to analyze it and then give the model summary to the person all in one dashboard is something that's really exciting to us. So one of the main products that we have at Carto is Builder, but by having all of these components that you can put together, you can build your own version of what you want Builder to be. And for us on the data science team, we want to build dashboards that allow users to extract all of the power they can from very specific analyses. So the one I was talking about before is just a gradient boosting regressor dashboard, but we also want to do things for optimization, so we can build a custom application for a client.
And as one last question, I'm wondering if you have any particular perspective on what you see as being some of the biggest difficulties or the biggest gap in the available tooling or technology for data management.
I think that there's a constant tension between having a ton of data and visualizing all of that data. I think that there's some compelling tools out there like MapD that visualize this data and do some basic analysis on it. I think the value for the person looking at the map isn't necessarily looking at all of the data, but looking at samples of the data and then making informed decisions on how to better analyze the data. So I still think that there is a tension between visualizing all of the data or trying to figure out what the intermediary is between visualizing all of your billion points or just visualizing a summary and then making decisions off of that. Yeah, that's the best answer I have for right now, yeah.
I'm here with Todd Blaschka from TigerGraph. So Todd, could you start by introducing yourself?
Yeah. Hello, I'm Todd Blaschka, the Chief Operating Officer for TigerGraph.
And so TigerGraph is a graph database company. So I don't know if you want to talk a bit about just graph databases in general, what they are, why they're special, or why somebody might want to use them over their standard relational database.
That's a great starting point. Graph databases have been around for almost 20 years. It's all based on graph theory, which is all about finding the interconnectedness and the meaning of the interconnected data. So when you think about relational databases require joins to find meaning between the data, and it is a very challenging thing for relational databases to do, even though they're called relational databases. Graph database is a natural way of how you think to naturally connect the dots. Think of Kevin Bacon and 6 degrees of separation. What's the connection? What's the relationship? That's what graph databases do. The first technology in the graph space came out in about 17 years ago, a technology called Neo4j. So they've been the pioneers in this space, and they've done a wonderful job getting graph databases into corporations. And then over the time, especially in the last couple of years, with the scale of big data, meaning large data sets, the requirements on graph have needed to be able to scale, to handle very large data sets, to be able to provide real-time updates, as well as be able to get a lot of data in there very fast. So from a scalable and real-time standpoint, that's where the customers are demanding graph databases. And so we're seeing a lot more adoption in the enterprises because they're able to apply to many different use cases.
And when people are dealing with relational databases, it's pretty easy to understand that the data just goes in rows. There are multiple columns to that row. So when you're modeling for a graph database, is there a different type of thought process that needs to go into how you store the data and the types of data that get stored in various nodes? Can you store data as part of the edge connections? Just wondering what the data modeling process looks like for that.
Excellent question. So from a data modeling, we often will take the data from relational databases and other data sources, and you really map it out. So is an account, is a user, but then you're looking at what are the relationships attached to those nodes or entities. For example, if it's a user, if it's Tobias, well, what device is Tobias using to make a payment on? Is it a phone? Is it an iPhone? What is the transaction device? All these attributes to Tobias, you want to be able to capture and analyze. And when you think about that in aggregate, how can that help better customer service by being able to know more about the behavior of the users in an aggregate standpoint? And that's where, coming from the modeling of graph, we're able to bring the data in and then be able to provide Graph Studio, which is a visual front end, to be able to explore the graph and look at the relationship. What is the closest relationship amongst multiple hops between this user and this user, or this customer and this customer, to find those relationships?
And so one of the things that you mentioned was that scaling graph databases is one of the current concerns, and I'm assuming has some technical difficulties associated. So how do you manage that at TigerGraph?
TigerGraph was developed from the ground up to be natively parallel. Our founders come from the world of MPP, massively parallel processing, such as Teradata, Twitter, which is actually just a big graph system. And what we did is built from the ground up to be able to scale out. So when you look at first generation graph, it was all running local on one machine. Second generation started applying the back end of Cassandra. So you had Cassandra storage, but you don't have the performance when you add that layer in there and it's not a native graph. So the third generation we developed using what we call native parallel graph technology to build a graph engine from scratch. We're using C++. And as part of that architecture, we're able to apply parallel processing to loading the data on a continuous basis, which also has been a very big challenge in the graph space, just loading data in, which in this day and age, it shouldn't be an issue, but it is an issue when you talk to customers about just trying to load in data. If I have terabytes of data, it may take them 15, 20 days to try to load data in. That's not going to help your business when you're just trying to get loading the data in. The second is the parallel computation. So every single node within the TigerGraph system is not only a storage unit, but also a computational unit. So we're applying the process of SQL-like programming, where you're able to do functions and build off each one of those nodes for an additional amount of computation. So everything's running in parallel to be able to update in real time as you are using the graph. So that brings in a whole nother level of use cases where you can provide real-time recommendation engines that are looking at not only what you've done historically or the shopper has done, but also what they're looking at today. If I'm looking at beach towels, well, if you're looking at beach towels, they may be interested in beach chairs, and you might be interested in umbrellas. So all of a sudden be able to provide a lot more information and relevant information to a shopper while they're browsing. And this is where Graph is connecting the relationship and also be able to bring back this information in sub-second query response times so that you can develop a much tighter relationship with your customer from this e-commerce example.
And would you use something like TigerGraph or a graph database in general as the primary data source, or would it generally be used in conjunction with a relational or others type of data storage?
Great question. Oftentimes it is being used as part of a system where customers may be doing machine learning, or they may be doing, developing some AI, and they have as part of their whole system, having data that may be stored in other data stores such as HDFS, and they want to be able to extract that to be able to generate new features that may go into machine learning. And that's where the data would come into TigerGraph, and that becomes a great aspect for data science professionals to be able to explore the data, look at where the attributes are, the connections, in order to extract new features that they can bring into machine learning. And so then that becomes part of the whole process. So the data can then come out and then either go into supervised or unsupervised learning examples. One customer that's in our telecommunication space, they're using us to help address real-time scamming on the phones. Think about you getting phone calls from people you don't know. Well, instead of just looking at what the phone number is, but if you know about the behavior of that number, is it all one-way calls? Is there any callbacks? You start looking at these kind of connections. Is there other people that you call that are also getting this number? This gives more insight into the relationship of the data, and that's able to help this customer extract new machine learning features that they can feed in so that they can reduce the number of fraudulent and spamming calls, because the real sophisticated phishers or spammers are the harder ones to find. They know how to skip the easy tests, so you're looking for the relationships and the behaviors of the calls in order to support that, and to be able to update that in real time so that every 2 hours they're updating their system to try to reduce the number of fraudulent and scamming calls that their customers are experiencing. You do that against us. They have 500 million subscribers today. 500 million subscribers, 8 calls. You're dealing with billions of events every single day. That's big data. That's where TigerGraph can help.
And what have you found to be some of the most difficult aspects of scaling and parallelizing graph data? And do you support anything along the lines of distributed transactions for that sort of query capability?
Yeah, great question. So from a distributed standpoint, we've architected the technology so it can scale out horizontally. So we have customers that may be running on 20 commodity machines, handling, terabytes and terabytes of data, billions of events. One of our largest customers is Alipay, which is, think of it as PayPal, but it's part of Alibaba, and it's 10 times bigger. They have 1 trillion vertices in their graph. So that's trillion with a T, the largest graph in the world. And they're handling billions of events per day. So they're scaling it out across 20 plus commodity machines, and that's all acting as one graph database because of our distributed technology.
And for somebody who wanted to get started with using TigerGraph, is it something that they would install on-premise, or is it a hosted platform? And what does the workflow look like for getting up and running with it?
Getting up and running is very easy. It is a software product that you can download and run locally, or you can run it in the cloud of your choice. We are not a hosted provider. It's not a SaaS service, but it's very easy to be able to get up and running. What we find with customers is if they know the data set that they want to bring in, it's very easy with our Graph Studio UI to be able to create the schema and then be able to load the data and then be able to explore the graph and then be able to generate queries using our GSQL, which the G stands for Graph SQL-like query language, to be able then to find insights in the data. And we have pre-built queries in there where they can look at shortest path, page rank, ways to help them understand their data and jumpstart their exploration of their graph.
And have you found that there are any sort of common difficulties or misconceptions about how to work with and analyze graph data as opposed to relational or document-oriented systems?
With graph, the challenge is the understanding what graph is. Most people have been trained on relational database. You think of everything as in columns and rows, and you're trying to find and build these joins. With graph, joins are natural. So it's the first learning curve of just understanding how to think about it differently, but you're actually thinking about how you normally do things today. It's a natural way of thinking about it. And then with document stores or time series, those are dimensions. Those are dimensions that you can apply in a graph database. So time series could be one attribute, location can be another. So there's many different attributes you can apply. So once someone starts understanding the thought process behind graph, then they start finding new ways in how to use it. I mean, some of the customers have told us, what we thought was impossible is now possible because we can understand and make sense and get insight in the data that we haven't been able to get to before.
And are there any other aspects of graph databases or TigerGraph that you think we should discuss a bit more?
With graph databases, my recommendation is go out and explore, test some graph databases. If you have a business case or you have a question you want to have answered, that is the best way to start, because then you could look at how you bring the data together. An example is I just met with a financial services firm, and what sounds like a simple question, I want to know how many wire transfers have an email, a phone number attached to it. The law requires that there must be a phone number attached to a wire transfer. But if you have multiple divisions in the bank and you have 70,000 wire transfers being done every single day, how do you find that information across 4 or 5 different divisions where data is stored in silos across those different areas? Well, that sounds like a very simple question, but relational database, it's a very hard thing to do. With graph, it's natural. but start with what question do you want to have answered, and then apply it and try TigerGraph.
And as a final question, what do you see as being the biggest challenge or gap in the available tooling or technology for data management that's currently available?
The biggest gap we see is aligning it to business cases. Technology has advanced with so much tooling out there. And when you look at the big data space, there's been so much movement about putting data, moving it from one place to another, but without asking what is the business benefit question. And that's where I think the data scientists are struggling, because there's all this tooling, they're trying to figure this out, but how does this line to really result in what a value is for an organization or for your project to be able to make sense of that?
Well, thank you for that. And for anybody who wants to follow up with you or TigerGraph, what would be the best way for them to do that?
www.tigergraph.com. Come there, try out the product.
Thank you very much.
Hey, thank you, Tobias.